Hello everyone.
Hello.
Hello everyone. Sorry for the interruption. So, good morning, or good afternoon, or good evening. Dear authors, distinguished session chair, and invited guests. Welcome to Technical Session 6E. On behalf of the Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Sustainable Development. That is ICT4SD 2026, being held in Goa, India. The 11th edition of the conference is being conducted in a hybrid mode. The physical conference is being held today in Goa, while the virtual conference is being conducted via Zoom from 9th to 11th July 2026. I hope you enjoyed today's informative and engaging technical presentations. In this presentation, we will have 10 paper presentations. Each presenter will be allotted 10 minutes for the presentation, followed by 2 minutes for Q&A. At the 9-minute mark, I will give a gentle reminder so that we can maintain the schedule. I also request all participants to stay connected with us until the closing remarks. If you have any questions or require any assistance during this session, please feel free to share it in the chat box. Now it's my privilege to introduce you to the session chair for this session. Our session chair is Suresh Limkar, who is an assistant professor at the University of Jammu, India, with 15 years of academic experience. His academic interests span Internet of Things, cloud computing, machine learning, deep learning, and cryptography. Dr. Limkar is dedicated to advancing research and education in emerging technologies, contributing to both scholarly development and the training of future computing professionals. Welcome, sir. We are really honored to have you here with us today. Would you please like to share a few words? Dr. Lemkar, would you please like to share a few words with us? Opening remarks? Okay, so we will start with the presentations. First, we have Deepak More presenting the paper titled A Deep Learning Based Vehicle Surveillance System for License Plate Recognition and Tracking.
Good afternoon, everyone. Okay, I'm sharing my screen. Is everyone hear me?
Yes, you're audible.
Okay. Okay. Yeah. So, good morning, everyone. Good morning. Good evening to everyone. Uh, Today, I'm going to present our research paper, Deep Learning Based Vehicle Surveillance System for License Plate Recognition. Uh, Based on vehicle surveillance system. Uh, the main goal of this research paper is to automatically detect, recognize, and track vehicle licenses, plates, and surveillance videos using deep learning and OCR technologies. So I'm just going to introduce you that how what this research paper is and what exactly now problems we are facing, what are the existing research already done regarding this uh, particular area. So if you know that nowadays there are a lot of millions of vehicles on the road, so manually monitoring them is very difficult. Automatic license plate recognitions or ALPR helps solve this problem by automatically detecting and reading license plates from images or videos. It is useful for traffic management, parking system, toll collections, and any law enforcement. So, if I take any real example, there are likely there are like a lot of problems we are having. Like if you have the videos, there might be the poor lighting. There's like a that different designs of number plates of car. Sometimes the motions are blurred, but sometimes the license plates are blocked, and these things are make challenging uh, for system to recognize the number plate. So our system is designed to overcome these challenges by using deep learning and advanced OCR techniques. So if we are talking about the existing gaps, and we did some survey, and what we studied in our survey is there are several existing methods already exist, and that each existing works has some limitations. Uh, Also, there is like a traditional image processing techniques are sensitive to lightning condition. Many existing deep learning models can detect license plate, but they don't provide a complete end-to-end solution. Some systems also struggle with OCR accuracy and vehicle tracking. Our proposed system combines robust plate detection, hybrid OCR, post-processing tracking, and an interactive dashboard into one complete solution, achieving higher accuracy than previous method. So if you are talking here about the existing work and the limitation for each area, like suppose we are talking about the traditional image processing method. So there is a limitation on existing system what we observe. They are sensitive to lighting, there is a blur or camera angles is not correct. So our proposed solutions, what we are going to do is like we did YOLO version 5 best robust detection, and then we use hybrid OCR after post processing some algorithms where uh, the the chances of reading and then converting that images or recognizing that text, that is done through the hybrid OCR post-processing algorithms. Uh, the next slide that I'm going to explain the architecture of our system, and this will use the overall workflow of our system, how it works, and what are the steps we are taken to find out our final output. So if you look at it, that first user, as I explained, that we have the interactive user interface where user can go and upload uh, the surveillance videos or images, and that videos is divided into individual frames. That unique session IDs will get created for that individual video, and once we uh, divide that surveillance video into individual frames, then each frames is processed by the YOLO version 5 model to detect the license plate. And once we achieve that, once we have that license plate ready, then next OCR extract that plate number, and we can apply that post-processing algorithm to remove the duplicate or any incorrect results before storing that information into the database. If you see that we are using the MongoDB, where we are securely storing all the informations after uh, doing the due intelligence, that uh, after post processing and remove the duplicate or incorrect result data. Finally, user can, as I said, that we have the interactive user interface where user can go and search for any vehicle information. We can just user can go and directly input the user number plate and retrieve all the related information what you're looking for. So I'm talking about the more about the YOLO version 5S detection pipeline. Here you can see how the detection process work. Each video is broken into the frames so that we achieve using the YOLO version 5. And YOLO version 5 detects that license plate with very high accuracy. Once the plate is detected, easy OCR processing algorithm read that text and crop images. Only valid license plates that meet our confidence criteria are stored in the database. The processing runs in the background, so the user interface remains smooth and responsive. Once a plate is recognized, once we that uh, number plate images uh, acquire,
Deepak,
then raw OCR results are not always accurate.
Deepak, sorry to interrupt you. Can you just focus on your main contribution?
I'll just go through the slide and then I'll uh, come to that point. Is it okay, Suresh?
Or just focus on the main contribution because rest thing doesn't make any sense.
Okay, Deepak, just go
Okay.
on the focus on the results.
Okay. So okay. Okay, so I'll just directly jump on the results where I can explain that when we do that research, then we did around 500 unique vehicles video surveillance videos, and then to evaluate our system, we tested using that uh, 500 different vehicle under various conditions. Our system achieve plate detection accuracy around, as you said, see that 94.2 percentage. Then our character recognition rate is almost 91.5 percentage, and full plate uh, recognition rate is 88.9 percentage. So keeping the false positive rate as low as 2.1%, that these results demonstrate that our post-processing techniques greatly improve the overall performance of the system. So if you see that raw YOLO version 5, the false positive 3.8 raw, or if you only use the raw OCR, then false positive rate are 8.2%. But as I said, we are using the hybrid model where we are using the YOLO version 5 and the OCR. We are able to achieve that false positive rate around 2.1%. So these are the like statistic of uh, uh, the detection and accuracy recognition. This is the comparison of the existing with the, this matrix is just showing that how we are comparing our solutions
Excuse
with
me.
existing methods.
Sorry to interrupt you. This is just a gentle reminder that you have 2 minutes left for your presentation. So please conclude
Oh,
accordingly.
okay. So I'll be very quick. So here you can just see that there is a comparison between the existing method and then our solution, proposed solution. So the last row here is just show what I previously explained in the previous slide, that how we achieve our baselines by improving the plate detection, character recognition, tracking real time, and visualizations. Okay, so I'll just jump on the conclusion. To conclude, we develop a complete AI-based vehicle surveillance system that combines deep learning, OCR, vehicle tracking, and interactive visualization into a single platform. This system performs well in real-world conditions and provides accurate license plate recognition. Uh, as we said, that in the future, we plan to improve its performance in bad weather, low light condition. Support might be the live video streaming where we can, in a real time, we can recognize the vehicle number plate and uh, characterize that. So we are towards that, and also we are trying to integrate this system with the smart city traffic management system. Uh, I think, yeah, that is our intention, and that I conclude my presentation. We would be happy to answer any questions.
Dr. Lemka, do you have any questions?
Yes, I have a couple of questions. Just wanted to know what were the challenges you have, major challenges you have identified, and what the solutions you have provided.
Dr. Surashlimkar, as I said, that majorly the challenges what we saw that with the existing system, and where we saw that the whatever the uh, the
So just
existing
just
system,
list out the
as
challenges
like
while implementing this system. What were the
Mhm.
challenges you identified? At least just list out one or two challenges.
The challenges is like yeah, the finding the as I said, like when we did the testing, that we find like 500 different videos, 500 types, like where we have the low conditions or the angles are different on the uh, videos. So yeah, those are the like the major challenges we found, and collecting that information, and also that while finding the accuracy, that whether our hybrid model using the OCR and YOLO5 will work together, or um, our main purpose was to get the greater accuracy in uh, full-fledged recognition.
Okay, from my end, questions are over.
Okay, thank you, Dr. Suresh Shankar. Thank you, everyone.
With active decoding for job shop scheduling.
So may I share my screen? Am I audible?
Yes, you are audible. Please share your screen.
Okay. Whether my screen is visible to you people?
Yes, it's visible.
Okay, so our paper title is Hybrid Particle Pelican Swarm Framework with Active Decoding for Job Shop Scheduling. Authors are myself, Dr. Sagar Sapkar, and Mr. Mahesh Singhe. I'm working at Walchand College of Engineering, Sangli, which is a government-aided autonomous college affiliated to Shivaji University, and presenting the paper in this 11th International Conference on ICT for Sustainable Development. So far scheduling is concerned, it is related with assigning the task to the various resources. And in the manufacturing environment, scheduling is concerned with assigning the jobs to the machines, assigning the jobs to the operations, likewise. So there are three types of manufacturing scheduling. One is flow shop scheduling, another is job shop scheduling, and third one is open shop scheduling. The problem which we have undertaken is related with the job shop scheduling, wherein the jobs are required to be allotted to the machines, so that a fixed set of operations required to be carried out on each and every machine. Of course, in the industrial environment, somewhat complicated and complex scenarios are there, and because of which certain assumptions are required to be made with certain objectives, and these problems are required to be attempted. Now, so far this problem is concerned, it is NP-hard, non-deterministic polynomial time hard problem, in which as the search space grows exponentially with increase in the job and machine combination. So exact methods like branch and bound, linear programming kind of algorithms are having their limitations to solve those problems related to the small instances only. But then for large instances, we have to go for using meta heuristics. And some of the researchers have tried to attempt those meta heuristics. But they have tried to decode those meta heuristics into semi-active schedules, which retain avoidable machine idle time. So what we thought of is to go towards active schedules and incorporate that, so that which contains the optimal solution will be useful, and it will active in decoding, and it can be hybridized with some sort of swab intelligence. So that was the thought process behind this. And then there are certain assumptions for this kind of job shop scenario is concerned. Each job visit, every So every job passes through a fixed sequence of machines. Every operation has a known processing time. A machine can work on only one operation at a time, and once it starts, it cannot be interrupted. So there is no ordering requirement between different jobs, only within the operations of the same job. So the objective of this study is to minimize the make span, meaning the time at which very last operation across this particular job shop scheduling problem will be completed. So accordingly, there are certain objectives or objective functions with which we have identified and attempted here to solve this particular problem. That is make span. Make span is nothing but the total completion time, as I already mentioned, and accordingly we can go for attempting the solution to this particular problem. So the mathematical model is required to be formulated, and the mathematical model enforces three things. Operations respect their sequence within a job. Machines never process more than one operation simultaneously, and all completion times remains non-negative. So the schedule is required to be decoded. For that purpose, first of all, by using semi-active schedule, how the job sequence gets developed, that is shown here with the help of Gantt chart. So consider three small job case, small machine job combination environment where three job, three machine example is shown here. If a solution is simply decoded in the order, it comes out for the optimization process, and a semi-active schedule will get obtained. And in this case, its make span is 21 time units. So it is indicated here, 21 time units. There are gaps in the timeline, particularly for machines 1 and 3, we can observe here. And then from that point of view, if each operation is checked before placing and before placing it and shifted left, whenever that shift does not delay, then it becomes the active schedule. And we are interested in getting the active schedule. So if we go for using that and shifting some of the activities towards left side, we can get the make span as 16 time units. So we have tried this active schedule to be incorporated into hybridized meta heuristics. So we are considered two meta heuristics here: particle swarm optimization and pelican optimization algorithm, and their their benefits, their capabilities are utilized here in order to get the optimal solution within less time span with more quality or better quality. Now, so far particle swarm optimization is concerned, it is again related with the search space, and it is pulled by their own base known position and swarm base known position. Based on that mathematical formulation of this particular particle swarm optimization is done. It's a well-established technique with strong convergence behavior. And the second is the pelican optimization algorithm, wherein which is a nature-inspired method that models how pelicans coordinate while hunting. So it has two phases. We have tried to consider the first phase and try to accommodate that phase in our hybridized algorithm. And accordingly, whatever mathematical model has been suggested, that is incorporated into that. So there are the role of PSO in this hybridized algorithm, and there is also Pelican optimization based on the full swarm at each generation as omega decreases linearly to Shen, and that omega is taken into consideration. C1 and C2, these are the coefficients. R1 and R2, these are the random numbers, these are taken into consideration. So velocity along with the position of the particle is taken into consideration. Here in this case, position of the particle is taken into consideration, and based on that the algorithm is executed.
Excuse me, Sagar. Sorry to
Yes.
interrupt you. This is just a gentle reminder that 2 minutes are left for your presentation.
Yes, I will finish in 2 minutes. So we start with the randomly generated population. Every candidate is converted into an active schedule and evaluated. A subset of population selected based on a prey ratio parameter and is updating during the Pelican algorithm's exploration phase, helping to maintain this diversity. Then in every generation, the entire swarm undergoes a particle swarm update with the inertia weight decreasing over time. So the search gradually shifts from broad exploration to focused exploitation. This loop continues until the algorithm reaches the maximum number of iterations or reaches a target mix span. Then in the experimental setup, we have considered, we have used C language, implemented C language and tested on 40 Lawrence benchmark instances, a standard data set in this particular field. And the parameters such as swarm size, the prey ratio, the inertia weight, bounds were tuned empirically on a subset of the smaller and medium-sized instances and then held fixed for full evaluation. Then each configuration was run 30 times to get statistically meaningful average. So accordingly, ARPD results are considered. So averaged across all 40 instances, our hybrid method achieved a mean deviation from the best known solutions of about 2.36% compared to 2.6% of standalone PSO and around 7.06% for Pelican algorithm. So to confirm that this difference wasn't due to chance, the Friedman test was conducted, yielding a p-value below 0.001, indicating statistical significance of this. So based on the Wilcoxon rank test, confirmed that the proposed hybrid performs significantly better than each standalone algorithm individually. Then it is also compared with existing hybrid as well as PSO algorithm from the literature, and it is compared by taking average relative percentage of excess or best known solution into consideration, and accordingly they are compared and the results are put here. And this NGPSO, which is the existing algorithm, reported an ARP of 2.5 and the proposed PSPOA reported ARP of 1.35 for 40 instances. Similarly, for other instances also, we got very better results than the existing meta-heuristics as well as hybrid heuristics. So takeaways are this hybrid PSPOA lowers ARP against every literature baseline tested with the largest margin against PSO on the 20 instance subset, like 0.24 against 2.6. So performance holds consistency as well along with stability. So in the nutshell, combining particle swarm optimization with the exploration phase of the Pelican algorithm and enforcing active schedule decoding throughout gives us method that is both more accurate and more consistent than its individual components. In the future scope, this particular kind of algorithm can be utilized in real world situation which is more dynamic, in which machine breakdowns, job arrivals, and other constraints are required to be taken into account. This kind of algorithm can further be improved for multi-objective uh, problems, and along with adaptive control in the prey ratio or inertia weight, the validation along with the industrial data set can be possible. and that is the future direction or scope of this particular work. Thank you very much.
Sir, I have only one question.
Please.
So, particles on optimization, you have used the word.
Yeah.
So, have you contributed something in the algorithm, or you have used as it is the algorithm?
No. What we did is that previously people used only semi-active schedule. We have developed the active schedule, and we have incorporated that into PSO as well. So that is our contribution, and we have contributed in that way. And then the newly established or developed algorithm, which is called as Pelican optimization algorithm, which is not hybridized with PSO and not attempted for this particular problem. That also we have hybridized, and that is our again contribution in this particular work.
Okay. From my end, questions are over.
Yes, please.
Thank you, Saga, for your presentation.
Okay, thank you very much.
Now we have Neeraj Dhoram presenting the paper titled AI-enabled IoT edge device for avalanche rescue in high-altitude areas.
Good afternoon, sir. Am I audible?
Yes, you're audible.
Okay, ma'am. Can I start? Can I share my screen?
Yes, you may start your presentation.
Okay. Is my screen visible, ma'am?
Yes, it's visible.
Okay. So, good afternoon, everyone. I am Neeraj Dhoran, and I am here to present my paper on AI-enabled IoT edge device for avalanche rescue in high-altitude areas. The authors are Shantanu Lohi and Neeraj Dhoran. I am presently in Ministry of Defense, working at Delhi. So, this is the outline of my presentation. Just a brief introduction. Whenever there is an avalanche, the rate of the chance of survival is inversely proportional to the time, and the window in which we can save the victim is going to be very less. Some of the recent incidents in the last 3 to 4 years, we've seen that most of the casualties uh, have been uh, have been due to the avalanche impact, and victims have been buried under the snow. So towards that, NDRF has put in a lot of efforts to work on the solution. Towards that, I want to propose my solution, which is AI-enabled IoT edge device. So with this, the problem statement for me is the existing methods of avalanche rescue, they require manual record to check the survivability chance of victim. And there is a need for faster and more precise tracking of health parameters so that we can prioritize the rescue of victim, and we can monitor the real life condition of victim when he has to be evacuated. So the objective of my paper is to develop a edge AI model which is based on IoT technology to detect, track, and record the health parameters of the victim who is trapped in avalanche. The related work, what I have researched is that most of the rescue efforts which are there, the tracker dogs are used to detect human lives who are buried under the snow. Then there is a manual recording method to analyze and assess the chance of survival. Use of beacons are also found when the individual is buried under the snow and he has to be located. So there is a scope wherein IoT and technology can be used for medical, for tracking and recording the medical condition of the victim towards rescue. The architecture of my system is like this. I have slave nodes which are mounted on the victim's body who are going for some kind of trekking or patrolling, and the sensors are integrated onto that node. The sensors are providing the data to the node which is seated on the body, and from there using IoT, it is relaying the information to the master node, which is a land based at a suitable vantage area, and it has got a line of sight connectivity with the slave node. The experimental setup which has been proposed on the slave node is that you have the sensors, that is the pulse oximeter and accelerometer, which is detecting the medical parameters of the individual. Along with that, there is a temperature sensor also, DS18B20, which detects the temperature of body, and it is being gathered, and using the LoRa module, it is being relayed to the master node. And since the master node is only one, and there are numerous slave nodes which are fitted on individual bodies, there has to be a sequential method in which each and every node has to be contacted at frequent intervals, and the data of health is captured at fixed intervals. So for that, I'm using the temporal model, using which the data is captured from the slave node, and then it is captured and it is being assessed at the master node to detect whether the condition of victim is healthy or he needs immediate rescue. So total of about 2000 data sets were captured, and the location and accuracy of the GPS chip which is fitted on the slave node was about 10 to 50 meters, and the accuracy which we were able to get is about 97%, and the system worked fine over a range of 4 to 5 kilometers. Though intermittent, there was some disturbance because of the uh, the disturbances in line of sight or intervening uh, land features, and the transmission success was almost 99%, except in the snowy weather conditions or when the cloud cover was high or because of some non line of sight area. So overall, what we found that the system worked well, and the accuracy achieved was very high, and the continuous monitoring of body condition was being taken at the at the victim location, and the data was getting relayed. And there were also the emergency alerts which could be which could be initiated the moment victim is impacted due to avalanche. Certain limitations: the performance of battery dropped drastically below minus 10 degrees Celsius, and the reliability of sensor also changes a bit when we are going to lower temperatures. This is just a comparison when we have a rescue with avalanche rescue device or without a rescue device. The future scope that I envisage for myself is that the efficiency of sensors can be further improved if available, and the detection accuracy can be further worked upon depending on the training of model. And if the IoT receiver, that is the master node, is mounted on drone or some aerial platform, then it can capture the data. And if there is a satellite based connectivity, it can further improve the efficiency of system. So towards the end, I can only say that AI and IoT has a potential to work as a solution for avalanche rescue in high altitude areas. Thank you so much. I am ready for questions now.
Author has presented a well-structured paper. From mine, there is no any question.
Thank you, Neeraj, for your presentation.
Thank you so much, ma'am.
Now we have Supriya Gode presenting their paper titled An Agentic AI-Driven Multimodal Framework for Women Health, focusing on stage-wise diagnostic of polycystic ovary syndrome. Supriya, your screen is visible, but I don't think you're audible.
Am I audible now?
Yes, you're audible.
And the screen is visible?
Yes.
Okay, thank you. Good afternoon, everyone. I am Supriya Gorde, a PhD scholar at Department of Information Technology, Government College of Engineering, Amravati. I'm representing this topic, an agentic AI-driven multimodal framework for women healthcare. It's a stage-wise diagnosis, polycystic ovary syndrome, under the guidance of Dr. Shantanu Lohi. The introduction of topic is PCOS is one of the most prevalent endocrine disorder among women of reproductive age, which increases the incidence in both urban and rural populations due to lifestyle transitions, nutritional imbalances, and limited awareness. As this happens, PCOD is the result of hormonal imbalances. So multiple hormones are imbalanced. That's the reason PCOS happens in the women body. So this new name is PMOS, so polyendocrine metabolic ovarian syndrome. And the early this uh, this has happened because of the multiple hormonal imbalance, and this leading to the infertility, sub-infertility in the future. And this is not only limited to the reproductive system or the ovarian syndrome, but it hampers the overall women health, like high sugar, high BP, and insulin resistance, obesity. There is a mental well-being as well. So the early diagnosis of this PCOD is required. So early diagnosis remains challenging due to fragmented healthcare access, socio-cultural stigma, and cost constraint. So this framework I am representing here, the stage-wise diagnosis and the cost-effective framework. The delayed diagnosis of PCOS may hamper the overall system and uh, prolong there is the prolonged imbalances of hormones in the women body. To detect that in the early stages, which will be helpful for uh, to uh, to stop the or to cure the infertility at the early stage. So this framework, we are trying to detect the PCOS, new name is PMOS, at the early stages. Early stage means from 12 to 19 years. Once we are able to diagnose the PCOS at the early stages, we may work on the infertility on the women at the early stages. And uh, like I mean, recently we know that IVF ratios are increasing because of the multiple issues. The women's are working, those stress factor is there, um, and lifestyle, nutritional. Because of these factors, the info that women health is impacting. So the problem statement, this framework will work on the PCOS to early diagnosis, stage wise, and the cost effective as well. So this is the objective. The first I mean, literature review for this. The recent research are available on the single stage diagnosis only. Few are working on the clinical data. Few stages are few research works on the only ultrasounds. So this will not become the cost effective, and this may take the longer time to diagnose the PCOS. To to work on this, the research gap is multi-stage stage a cost-effective framework. So Here we approximately collected the 200 entries from the local hospitals, and through the few questionnaires to the patients, and SVM2 categorize PCOS or PMOS cases, then random forest 2 handling the mixed data types, providing the features importance, XJB2 prediction of accuracy of diagnosis, uh, and neural network to capture the non-linear and complex non-linear relationship. As this is the agentic AI, so three agents we are considered here: the clinical agent, the hormonal, and ultrasound. Clinical will be collecting the data through clinical, and then plus the lifestyle data and the nutritional data as well, and then hormonal agents. So we are collecting the hormonal different hormonal tests, the readings of the hormones. And sono agent means we are collecting the ultrasound, we're working on the ultrasound images. This is the framework collection of data. Then this is stage wise. Stage 1, the first agent will work the clinical plus lifestyle plus emotional health data. We are working on this. Basis on this, we may detect the PCOS. If we could find the PCOS cases on the stage 1, then do not need to go to the stage 2 and stage 3. So this is kind of a cost effective and the time we can predict the PCOS cases within the given timeline. Then stage two will work on the hormonal readings. If we could find that the stage in the stage 1 that this is a PCOS case, then to confirm it, we can go to the stage 2 hormonal readings. Then stage 3, if the critical case is there, then we can go to the ultrasound, and then we can find out the final PCOS case or non-PCOS case. Basis on that, we can recommend the few changes in the lifestyle or the medicine with the help of the uh, uh, healthcare professional. This is the result. The conventional full diagnosis workflow, the like we are working on the stage 1, stage 2, stage 3. This is that becomes the more cost taking the this is not the cost effective. And then ML based single stage, this is reducing the cost but not as such. And then proposed stage wise agentic AI system, which is cost is minimizing, and it is approximate 60%. uh, this is the diagrammatic representation of the result. The conclusion, this AI driven PCOS screening PCOS framework will be helpful for the patients and the working professional, I mean healthcare professional. We can get the accuracy stage wise, and it will become the cost effective. And future scope is, if this framework works, and then in future we can deploy it at the PHC and recommendation system as for the telemedicine. As this will be specifically helpful in the rural areas, as there is the lack of awareness and we have a social taboo as well, how we can treat for the reproduction. And I am, any women may think that this is maybe a taboo, also social stigma. So in that case, this framework will be helpful in future. These are the references. Thank you. Uh, any suggestions?
Yeah. So I just one question. As you have mentioned, it's a multi-model, right?
Yes, sir.
So how the multi-model is working out? Because you have multiple sources of data sets, right? That need to
Hmm.
be combined at one particular point. So what the function or what the mathematics you are using behind it?
So multi-model means the first, it's multi-stage and multi-model, as we need diverse data to identify the PCOS case. So definitely this is a multi-model, and multi-stage means it's a stage-wise first clinical data we are collecting. Basis on that, there are some symptoms. So obesity, hirsutism, and multiple
No,
symptoms are there,
I got it.
right?
I got these points. Just wanted
Okay.
to know how you are
Mm-hmm.
going to combine this data at one particular point, as it's a diverse data set, because features, parameters are different for the different cases.
Hmm.
How you are going to combine it to make a decision?
Uh,
May I know the diverse dataset format extensions
um,
like CSV file, JSON
CSV
file?
file only. So CSV file only.
All are having CSV file.
First, on a stage one, it's a CSV file, and we are working on the ultrasound images. That's not, I mean,
So that's
it's
my concern. Na? How you are going to come at one particular point where you have a diverse data set, like one is CSV, another one
huh.
is a image. So how you come out at a one particular point?
So as of now, I worked on the CSV files only. So I'm still working on this framework, uh, uh, specifically on ultrasound.
Then what is your proposed method in this particular paper? What is your research contribution in this paper?
Uh, this is the, I mean, stage wise and cost effective.
I'm asking research contribution in the paper.
Um,
Hello, Supriya,
yes,
can
sir.
you hear me?
Yes, 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 yes.
I just wanted to know what is your research contribution in the paper.
Uh, research contribution is I'm working on a different data sets only. So that is what I mean, my proposed contribution.
Working on different data set is not the research contribution. Na? Hope you can
Uh,
understand.
yeah, yeah.
Research contribution in the sense, what's the novel parameter you have identified and how novelty you have.
So novelty in the sense, I mean, the cost. I was working on the cost-effective framework and the features, I mean, for the, I mean, different data sets are using. I'm using it. So the for it, I mean, selecting the some features by using, I mean, meta heuristic algorithms.
And how these agents will communicate to each other. As you have just mentioned, there are three agents listed out in your PPTs
Hmm.
at taking a particular data set. So how agents will consume the data or how the agents will uh, take the input.
Um,
Okay, from my end, questions are over. You just need to think on these questions
yes, so thank you, sir.
clearly and
Yes,
come up with
definitely.
some answers for these questions so that will be helpful for your final defense or research progress seminars.
Sure, sir, sure. Thank you, sir.
Thank you, Supriya, for your presentation. Now we have Meenu presenting the paper titled Artificial Intelligence and Gender Justice in Panchayati Raj Institutions, a review.
Am I audible?
Yes, you're audible.
Good evening, everyone. I am Meenu, research scholar, Uttaranchal University Law College, Dehradun. And my topic is Artificial Intelligence and Gender Justice in Panchayati Raj Institutions, a review. Here, the introduction. Slide. Artificial intelligence is transforming many sectors by improving decision making and knowledge management. However, women remaining underrepresented in AI due to barriers, unequal access to education resources, and career opportunities. This review examines the current status of women participation, identify challenges, limited skill development opportunities, and low confidence. It emphasizes that greater participation of women in essential is not only for achieving gender justice but also for reducing bias in AI systems and ensuring fairness, trustworthiness, and development. The review concludes that inclusive policies, equal access to AI, education, training, and institutional support are necessary to increase women's involvement and promote sustainable development, AI development. Our next heading is that Panchayati Raj system. Panchayati Raj system increases the decentralized democratic governance, reserving seats for women, promoting uh, inclusion and participation. Gender justice under this concept attempts to turn formal representation into substantive empowerment, addressing structural constraints, uh, patriarchal, patriarchal conventions, and institutional inequalities which restrict effective decision making by women as a part of local governance. This involvement of women in Panchayati Raj has greatly enhanced the political representation and inclusion of women through reservations, although women have continued to face some challenges of proxy participation, literacy, and patriarchy restrictions. Women are increasingly playing a role in the governance of their local areas in decision making and development priorities, advancing the cause of grassroots empowerment and democratic decentralization. Now the coming heading is balancing process in challenges in women's political participation. Although Haryana provides numerical representation in terms of reservation, women in Haryana are still largely related to non-significant participation in politics in the state. Patriarchal rules, males' dominance, decision-making, and family-based politics are entry restrict autonomy, and education has not played a significant role in enhancing the influence of women in governance or in leadership opportunities. AI in the government promotes efficiency and service delivery but poses a challenge of bias, transparency, and accountability. Here is overview of AI in local governance. Artificial intelligence refers to computer system that can perform tasks requiring human intelligence, such as learning, analyzing data, and making decisions. In local governance, AI improves public services by automating administrative tasks, supporting better decision making, managing infrastructure, and increasing citizen engagement. It helps governments deliver services more efficiently and respond to community need effectively. However, the use of AI also raises challenges including data privacy, ethical concerns, high implementation cost, and the need of skilled professional. Therefore, AI should be implemented responsibly to maximize its benefit while minimizing risk and ensuring inclusive, transparent, and accountable governance. Artificial intelligence for assessing gender justice in Panchayati Raj institutions. The 73rd Constitutional Amendment strengthened decentralization by increasing the representation of women in Panchayati Raj institutions through reserved seats, and effectiveness is enhanced by education, leadership, political support, and training. Artificial intelligence enhances governance through analysis of various data like demography, weather, and service offered to citizens to help them make informed decisions. It makes the governance systems more efficient, transparent, and service delivery. Whereas explainable artificial intelligence makes the governance system accountable, transparent, and service delivery clear. The system has machine learning that allows automated analysis of the collected data. It enhances efficiency and accuracy and has issues such as complex language and fairness. Artificial intelligence in analyzing role of women in governance. It has been proven that increased female leadership representation reduces gender discrimination, enhances employment stability, and strengthens the policies to better represent the need and financial security of women. They are also capable of pretending their hidden patterns, labor participation, and financial independence, as well as legal access, uncover hidden patterns, and support data driven policies to reduce gender inequality and improve decision making. Generative AI also help women feel more empowered by making a variety of skills more accessible to them, giving them more confidence, and making them more involved in innovation. The use of AI tools such as ChatGPT can help women not only learn but also solve problems and develop as a leader in the era of AI. AI can help empower women by providing them with high skill job, more demand on cross-disciplinary skills, and possibly reducing gender gaps. Generative AI is transforming the leadership of women by increasing the number of opportunities in the areas of research, innovation, and decision making, as well as revealing structural bias. Knowledge creation and leadership visibility could be supported by tools such as ChatGPT and Gemini, but bias training data can be used to reinforce stereotypes, which hinders the ability to prioritize women in high impact roles. This concern of fairness, inclusive data sets, and ethical AI design is zero crucial to enhance the impact of women in leadership, equitable participation, and comfortable technological development with the gender equality objectives such as United Nations. Here we have the conclusion. The review highlights how artificial intelligence can promote gender justice and women empowerment in Panchayati Raj institutions. Although reservations have increased women representation, many still face challenges such as social norms, patriarchy, and institutional barriers that limit their active participation. AI can improve local governance by making decisions more transparent, efficient, and evidence based. Through machine learning, the data analyzed, AI can identify gender gaps, monitor women's participation, and support inclusive policy making. Generative AI tools such as ChatGPT can also strengthen women's leadership by supporting training, knowledge sharing, and capacity building. AI has significant potential to strengthen women empowerment and gender equitable governance, but its success depends on combining technological innovation with ethical practices and inclusive public policies. Recommendations: build capacity building systems that are inclusive in order to increase the technical skills and leadership of women in AI enabled governance systems. Ensure that you are using diverse, representative, and unbiased data to make things fair and reduce the gap in terms of gender differences in AI performance. Enact ethical modes of AI governance that are centered on transparency, accountability, and gender sensitivity. Amplify the image and the involvement of women in AI design, AI decision making, and policy making. Apply the latest state of the art generative AI tools such as ChatGPT to support knowledge discrimination, digital literacy, and empowerment initiatives. Thank you so much.
Dr. Limka, do you have any questions?
No, ma'am, I don't have any questions for this topic.
All right. Thank you for your presentation. Up next, we have Piyush Awasthi presenting the paper titled Gen Z Responses to AI-Generated Images, a mediation analysis of credibility, aesthetics, and skepticism.
Hello, am I audible?
Yes, you're audible.
Okay.
Ma'am, till how many papers are left? Hello, may I know number of papers left?
4.
4.
Yes, sir.
Okay.
Just 1 second.
Piyush, please hurry up. We're already behind schedule. If you cannot present right now, you can present next. We'll have the next author present right now.
Ma'am, I'm ready to present. Share. Okay. Is my screen is visible? Hello.
Yes, it's visible.
Okay. Good afternoon, everyone. My name is Piyush Avasthi. I'm a student of Central University of Punjab, journalism student. My topic is Gen Z response to AI-generated image, mediation, analysis of credibility, aesthetics, and skepticism. So, as we all know, now the AI-generated content is become a part of our daily life. And as I mentioned in my topic, Gen Z. So Gen Z is the generation who interact more with the AI generated content. Like we grown up with the technology, so this new technology. So we are spend more time on social media and we interact with more AI generated content. So this raises questions like, like they uh, do they believe or trust on that AI generated content, or does that visual beauty is influence their user behavior, or that skepticism or doubtfulness influence their user behavior? So to understand this all, we did conduct my research. My like with me, my author is like Muhammad Dr. Muhammad Aleem Khan. My name is Piyush Avasthi, Vishnu Achyuta Menon, or Satish Kumar TK. We four all did this, and this is my introduction first slide, and I divided it to 4 points. Like first is ubiquitous visuals. Like as we all know that everywhere on social media, Instagram, Facebook, YouTube, everywhere now we can see the AI generated content. You can see visuals, photographs. Nowadays, on Instagram, lots of AI generated visuals we can see. In I have a good example, like in my university also, from last 1 year, very rapidly students are using the AI generated content for their academic work, or as well as for their events and festival, anything, Eid, yeah, Holi, Diwali, any event, they just give the prompt to AI and make pamphlets, invitation cards, and circulate it into university hostel group and everywhere. And second point is this Gen Z at the center. As I mentioned in my title, when I explaining my title, Gen Z is the generation who's grown up with the technology. So Gen Z will shape how the AI visuals are adopted in next. It is how the Gen Z will decide that what is the future of actually AI generated content, whether it's good, whether it's bad. So it's all depends on a Gen Z. All not, but they are like the major influence how it will impact on AI visuals, how people will adopt, and that blurred authenticity, like machine learning now generated imagery that reveal human made art. Like we can easily understand that now AI are making content like similar as humans also making like. But like AI is taking less time as compared to men. Like I'm a journalism student, and for my video editing and making a reels, making any post, I'm also using AI generated content. It is very easy to make generate a content for my script. For ideation, I use AI so save my script. So there is a lots of things we can do through AI. So it's like blurred the authenticity. Like nowadays all like human made arts and AI generated content both are like in most of the parameters as they are looking like similar. Some of like us we can find out the like difference. Otherwise it is very difficult to found difference between them, like trust under the pressure. Like I already mentioned that when that boundary will blur, then it's become more chances to people use that as for their own benefits to defame someone for misusing of any to
You,
circulate mission. हाँ sir.
sorry to interrupt you. Can you just come out with the novel contribution, research
Okay,
contribution
sir.
in the
Sorry.
paper?
Okay, sir. Okay,
As
sir. I
we are
understand.
time.
Okay, sir. I'm like going very not going into deep, just explaining in a like short time. This is two pathway of behavioral intention, like is perceived usefulness, like cognitive channels. मतलब how the credible of image. It's if the image are credible, then Gen Z is thinking it's useful or they will use. And second is the affective channels, like technology anxiety, like if they feel it's attractive and uh, it is looking good, beautiful, then they will more about wants to use. So this is my two RQs. Like in downside I mentioned, like how does perceived information credible influence behavior intention through perceived usefulness. And second RQ is does static quality influence behavior intention through ease of use and usefulness. And for my literature of review, I found this four points which I mentioned. And the major, if I explain in very short term, like what is my gap is like credible derives purpose behavior, and second is the engagement. And if we'll go to on my this research gap which I address is like previous studies look at the AI generated image, but they didn't not clearly explain whether the people AI, like people use AI because the images are attractive or because they are useful or easy to use. They also didn't study, they did not like not study whether doubts about AI created anxiety, which they like affect people's decision to use AI or not. So in our study, we examine both these factors together, and this is the result. Like we conduct this data in Central University of Punjab, like our respondent in four. We for seven structural construct we measured, and this is like how we conduct this research. And the third is this is the RQs one, like credibility, divine intention through usefulness. Like if we found that image is trustworthy, is like it will. If we found that image is credible, then it's we think that it is like useful. And if we think that it is useful, then we will it will influence our behavior to use or not use. That it's depend on that user. And second is the static alone. This is RQs too. Static alone do not move behavior. Like is, there is some factor where we can say that in static evolution is influencing, but not only alone static. Like beautiful, if anything, if it is not important that if any image is looking beauty full or attractive, then only people will use that. It's depend on several factors if they found trustworthy or not. Or so I like as you can see that static quality. If they found it is static, then it's easy to use. And then like if it is easy to use, if they found it is useful, then it will change their behavior about to use or not AI generated content. Second is third is results is like skepticism pathway is like skepticism breeds anxiety which saved behavior. If I have doubt about AI generated content, it is real or not. Like so it will influence my uh, user behavior. If I found it is uh, if I found if I have doubt about if I like for example, if I have doubt about any technology AI generated content, so it will influence and technical anxiety that it like should I use or not. So this will influence their user behavior towards AI generated content. And my discussion there is a like first is credibility is the stronger level, that as I mentioned that if they found is trustworthy, credible and authentic, then they will use. Beauty is not enough on its own, like only static. And if any
Excuse me.
image uh,
This is a gentle reminder that 2 minutes are left for your
okay,
presentation.
ma'am. But I'm just like about to complete. The beauty is not enough on its own, like only beauty is not influence the user behavior of AI generated content. Emotion is a hidden barrier. I mentioned, like as I mentioned in skepticism is like, if there is a doubt, so it directly not affect user behavior, but it will create a, in my mind, should I use AI generated content or not? Like nowadays, it's day by day decreasing because people make found that AI generated images are easy to create. But earlier, what's happened when the AI came, that time people don't people have fear to give their data also. They are thinking, oh, I will not give my personal image. But nowadays they're giving Gemini and ChatGPT and several AI Hazen to create their own videos and all. So there is a two system. One like outcome I mentioned in my first slide, second slide, cognitive channels and anxiety. Like if they found it useful or not, then it will also influence, or emotional behavior also influence, like it is looking good or not. It both will shape their mind to use the AI generated content. And in conclusion, like the trust and emotions, not just a beauty driven adoption, like it's important, like if these three all may these three all equally the like trust and emotions are important factor to use, but not only like beauty. Then I mentioned in my conclusion, like Gen Z's willingness to engage with the AI generated visual rest largely on credible and useful and emotion rather than aesthetic alone. So this is my overall my well, research. Thank you so much for giving me this opportunity. Now I'm open for a question. And there is my some selected research preference. Hello.
Piyush, you haven't cited any of the reference you have used for your research work and in entire slides.
Hello.
Hello, Piyush. Can you hear me?
Yeah, yes, sir. Hello.
So you have not cited any of the reference in your entire PPTs.
Uh, are you talking about review of literature? Like I mentioned some references here. You can I don't know how to show. Here my PPT is visible.
Yes, it's visible.
Okay, okay.
Okay. We'll move for the next presentation, madam.
Okay, sir. Thank you for your presentation, Piyush.
Okay, thank you, sir. Thank you so much, ma'am. Any
Next,
suggestions, sir?
I think, Piyush, there are no suggestions as of now. So
Okay, 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 okay,
our
okay, okay.
next presenter is Meet Yogi, who will be presenting their paper titled Improving Bird Sound Classification via IMF Decomposition and CNN-based Spectrogram Analysis.
Hi, am I audible?
Yes, you're audible.
Yeah, I'm presenting my screen.
Your screen is invisible. Oh,
Is it visible now?
yes, it is.
Yeah, so hi, my name is Meet, and I'm been presenting the paper on the bird sound classification via IMF decomposition and CNS based spectrogram analysis. So let's move ahead with this part. I'll directly and quickly go to the approach and the methodology we have used, and let me initiate this thing with why we need to have the bird sound classification. Uh, so as we know, there are a very large number of species available in our entire world, with having different kinds of speech or sound, we can say. And there are also species which come under the endangered species or extinct species, and such recordings of the or the sounds of the bird helps us to determine which species are there, the population, and we can again move forward of identification of the communication between them once we deal with the bird sound classification. Okay, so I'll move to the data preparation part over here. So we have used the Xenosanto data set, which is openly available data set. There are multiple species audio recordings available all over the globe, right? And we have selected this 10 species out of the all the species available, and we have clicked the audio files into 15 seconds. Now, as we know that this is an open source data set, there are multiple uploads available from different users. Some of them have the noise, some of have the gaps in between or silence, we can say, and there are very high pitch, low pitch sound of these species are available. We have done the data processing part where we have dropped the clips where there is a silence. We have dropped the clips where there is a noise, and that's how we prepared these samples. So we have prepared 3,000 samples per class, and then so we have around 30,000 samples for entire 10 species. Okay. Now, this is the proposed approach for the entire the paper and the solution. We have the original audio available, right? And then we have used the EMD mechanism, which is a empirical mode decomposition. So the purpose of this is that we use an decomposition method on an audio of the bird sound, which extracts the features from the audio signals in form of IMF. Now, the role of IMF is that extracts the high level of features, the concentrated features in the initial part. So, which is this 1, 2, and 3, and then so on. We can see that there are less number of features available when you move on. Now, once the features are collected in the form of IMF, we have converted those audio files into spectrograms. Now, spectrograms are what? They are the image form of the audio, where we can see in the form of heat map. Now, when there is a high heat level available, which means that the pitch is high and have the like more features over there, and we pass that entire spectrogram in form of images to our CNN architecture, which we'll see in the further slides. Where once it go through the CNN architecture, we get the final class of what the bird sound is of. Right. Okay. So this is all about the empirical mode decomposition, which I already explained, where we are using the extracting the IMF of the audio files, and we are using the top three for our training purpose using this spectrogram on CNN architecture. So this is our CNN architecture. We have like we tried different CNN architectures. We started with a very smaller CNN architecture, and then we went beyond, but up to a point where we found that we got the accuracy that was needed, right? So we passed the spectrogram. We have two convolution layers and max pools, right? And at the end we have the classifier, which gives us the output of the probability that out of the 10, which class is the highest probability of this spectrogram of the bird species. Right. So as we can see here, we ran this for around 3 epochs, batch size of 8, and we ran on a very less amount of CPU, less amount of resources, so that it can become easily, we can say, evaluating, so that we can get the output with less resources. Okay. Now, these are some of the images of in comparison with the original waveform versus the IMF. So here we have three IMFs, 1, 2, and 3, and this is the original waveform. We can say that the three IMFs are very much similar to the original waveform, or we can say the spectrogram, because the initial IMFs have the highest amount of features available of the audio file. Now let's compare the accuracy splits across the different IMFs. So this is the representation where we can see that the IMF 1, 2, 3, the accuracy goes around 99, right? And with the IMF 1, the first one has the best average accuracy of 99.81. We also tried with different IMFs further than third one, but as we can see from the table itself, from the third one we can see there is a drop in the accuracy, which means that there is a loss of the information while extracting the features from the audio file. Okay, and also and if we use the original one, we don't get that maximum or the optimum accuracy which is needed. Now this is the contribution part for IMF. How much is the accuracy proportion available? Okay, so I'll conclude this part. Uh, so what we have done, that I already talked about, what we are going to do in our future work is that we'll access the more amount of data, and also try with different other methods where we can vividly and distinctively classify the large number of species, not just 10 but large number of species, and train a large number of data set, so we have a more generalized approach and more generalized model for the classification purposes of the bird sound. Here are the references for the presentation. Thank you, and I'm open to the questions.
I have just only one suggestion because everything you have cleared in your presentation. But only one
Yeah,
suggestion: try to avoid the auto-generated PPTs. So try to make it
yeah,
the plain PPTs, and inside that you just cite the relevant literature, most
right,
relevant literature, not all the literature, most relevant
right,
literature in wherever you need this is required.
right.
Rest everything is perfect. I think you are not from the academia, right?
No, I'm from Pet Puja. I'm leading the AI team over here.
Mm-hmm. Okay, sure. And what this research work is it your PhD work?
Okay, so this is like I'm doing a collaboration with the NIGMA students and professor, right? So I'm doing mentorship, and I'm doing like just paper like R&D and all stuff. So I'm interested in doing R&D, right? So I just collaborate with those guys. Those guys are students, so they present in bachelors or in masters along with their professor, and I contribute to them.
Okay. Is there any scope for collaboration of for my students?
Yeah, sure, definitely.
So how should I approach, or can I get your mail ID?
Yeah, sure. You can contact me on meet.yogi
Uh,
at the com.
okay, sure. Thank you.
Yeah, anything else? Any questions?
Nothing. I think everything you have crystal clear covered all the aspects. There is no any lagging in between that.
Okay. Yeah. Thank you.
Thank you for your presentation. Now we have Path Parange presenting the paper titled Leaf Disease Detection and Classification Using Deep Learning and Computer Vision for Crops.
Hello, and I am audible.
Yes, you're audible.
Okay. Okay, so is this my screen is visible?
Yes, it's visible.
Uh, okay. So hello everyone. My name is Parth Palange, and my co-author is Dr. Wahida Attar. I'm doing my MTech in COEP Technological University, Pune. So my research work title is like leaf disease detection and classification using deep learning and computer vision for crops. So firstly, I will introduce what like uh, I'm working on and like what are the problem we are solving. So the research is situated on the like computer vision and precision agriculture for the like regional crop health. So in the Maharashtra, there is like field level diagnosis happen in the very manual way. So we are like taking one huge amount of data set from the Maharashtra region, and we are doing these disease detection on the 16 major crops varieties. So like we are doing like we are using explainable AI in this. So it should not like just doing fine tuning and training the models, but also like we are actually localizing the diseases and taking the features. So what I get the research gap is like there is like deep learning and dataset gap. So it is like there are like mostly people are using datasets which are only mobile captured or like only leaf captured. So and also there is like transfer learning and model efficiency is the research, if I can say, because most solutions are using a single crop uh, for only single crops. No one is like going for multiple crops. Like they are going, there are some papers which are like two or three crops, but not like multiple crops. So and unified detection. So like there is like only disease detection or pest detection, not like both. And also I like explain like explainability and trustworthy. So we are like not just doing the things and like taking the accuracy and highest accuracy, and this is not we are just doing. So this is my system architecture. So there are like data pre-processing. After that, we are like doing transfer learning and object detection also. And then we are like model evaluation. We are doing model evaluation. After the model evaluation, like we are like analyzing the model evaluation parameters, and then we are doing fine tuning and also hyperparameter search, and also we are at the same level we are like doing explainable AI. So like how the model taking the features like that. So firstly, like I will like introduce like data pre-processing. So like we are taking the images, collecting the images from the crop data sets, and then validate images by removing corruptible or mislabeled samples. Then we are like applying the filters for like uh, if some images are like in the not good quality images like that. So we are like applying the filters, so improving the feature visibility. Then like we are doing data augmentation for like for imbalance data set. We are like doing data augmentation, so data should be balanced. Yeah, so it will like output will be getting like clean and augmented leap image data set. Then like we are like transfer learning. In the transfer learning, we are not doing model training from scratch. Rather than that, we are like taking the good previous fine-tuned models, pre-trained models, sorry, and then we are doing fine-tuning on them. And like there are like ResNet, MobileNet, EfficientNet, DenseNet are like giving very good accuracy on the ImageNet dataset, which is like so we are like initializing pre-trained ImageNet weights, then replace the classification layer where the previously it is like 1000 classification. Now we are like giving how many uh, classes of disease are there, and then we are trained on the leaf disease data set. And then we are like comparing the which architecture is like good, and then only we are like going for this. So in yeah, and object detection. So it is also like in classification, what we are doing, what we are getting is predicting which disease. But in the object detection, we are like uh, taking that region also. So here we are like implementing YOLO, faster CNN, and efficient date for the better, hmm, better and like accurate regions. So purpose is like localize disease areas, improve disease identification, and here we are like comparing one stage and two stage detector. So like YOLO is one stage, efficient date is one stage, faster RCNN is two stage. But we are not going for like YOLO only or like any one only. We are like doing all the thing, and then we are like analyzing which model should be good for us. So this give us output as a bounding boxes around like infected regions. So then like model evaluation and error analysis we are doing. So here we are using like accuracy, precision, recall, F1 square. So we compare classification and detection models and select the best performing model from this model. And then we are like fine tuning and hyperparameter search. Here we are improve model performance. So model is before is like 90%. So like we are like doing fine tuning and improving to 90 to like 95, like that. So here like we are like optimizing like learning rate, batch size, number of epochs, dropout, optimizers electing. So like we are getting higher and better generalization. So this is yeah, and after that we are like doing explainable AI. So it is like we are doing, we are using AdCam and GradCam plus plus. So and and reading like heat maps, and in that heat maps we are like visualize the features. So it will highlight infected regions responsible for prediction. Also increases model transparency, improve trust in AI-based diagnosis. So this is like our system architecture. So here, like user will get the input, like image. Here will be like image guardrail for the classification for the model. Then after that, image guardrail, it will be like disease classification models uh, for that specific crop. And also we are like doing fine tuning on them also, and then will be a XA. So this is what I just tell you workflow. So accept the leaf image for analysis, then ensure only high quality images are processed, then identify the disease affecting the leaf, and then provide the final diagnosis. And explainable AI is doing like make the prediction interpretable. And for the continuous learning, we are like fine tuning. So improve model performance over time. So like that. So here is the, like one of my best result. So it is giving me like 99%. So it will be like it is not just giving me 99%. It has also confidence like 98. I take the one example of the data set, and it is like giving me 98% confidence. You can see here. And it is not just giving the confidence or just giving the accuracy, but here is the disease and the highlighted XAI result here also. So it the model is taking that feature only. It is not like the model is taking another feature and just giving the good accuracy. It is not that. So yes. So like I would like conclude. So this is a successfully implement hierarchical deep learning framework for multi-crop disease diagnosis for the massive data set. So by utilizing a two-stage workflow, first identify the crop species and then routing to one of 16 specialized submodels. The system achieves superior accuracy and modularity over traditional flat classifiers, and also like integrate expert validation. Explainable AI ensures that the model predictions are based on actual pathological markers rather than background noise. So it is not taking the background noise. So thank you, sir. Any question?
No questions from my end.
Okay, sir. So can I just stop sharing screen?
Yeah, you can stop sharing. And
Oh,
is there
okay, sir.
anyone left for the presentation?
Yes, sir. We have a last author for today. The next presenter is Sailesh Kumar, presenting their paper titled Performance Optimization of Multi-User MM-Wave Massive MIMO by Implementing Meta-Heuristic Hybrid Precoding.
Am I audible, ma'am?
Yes, you're audible.
Sir, good afternoon, sir. Good afternoon, all. I am presenting the paper on my topic performance optimization of multi-user millimeter wave massive MIMO by implementing meteoristic hybrid precoding. I am the PhD research scholar at the Department of Electronics at RCOM Nagpur, and my guide is Dr. Jagdish D. Kene, sir. So basically, to begin with, millimeter wave technology offers a massive bandwidth. What we are running in future wireless communication system, we are lagging in the spectrum space because what we are having in sub 6 gigahertz bands, already that spectrum is get crowded. So we will be looking for the new domains where we can have a higher spectrum. There we will have the solution in terms of millimeter wave configuration, millimeter wave uh, spectrum space. To begin with, millimeter wave technology offers a massive bandwidth, operating in the gigahertz, 30 to 300 gigahertz of spectrum. But beginning, since we are having this high frequency spectrum expansion, that advantage we are having, and similarly, we will be having millimeter wave is having a very short wavelength. So we can have a large number of antennas that is get packed into a tiny space. But the serious problem that comes with the millimeter wave is a serious path loss. So we will be having small cells to avoid that. The need for hybrid to mitigate this, we rely on highly directional spatial precoding. So here we will be having to bring hybrid precode traditional digital in previously we are having the traditional digital precoding where we are having a single RF chain dedicated to a single antenna. Since we are moving towards the millimeter wave, it is not possible to have, we are having hundreds of antennas that is get packed into the tiny space in terms of we are having the concept of massive MIMO. There it is not possible to have a dedicated RF chain to a specific antenna. That is why we are coming with the next hybrid precoding, where we are having a baseband precoder named as FBB, and then we are having the RF precoder. The combination of these two, we are saying it's a hybrid precoding. And we are strategically dividing the processing into a large scale analog stage using phase shifter and small digital stage by drastically reducing the RF chance. This is what we can have the system architecture. In our system architecture of hybrid precoding, we are having the baseband precoder FBB. With it, we are having RF precoder FRF, and whatever the data stream that is going to the baseband precoder. Then we are having RF precoder, and by antenna, it is receiving by the mobile station. So this is what the transmitted downlink signal is there. X is equal to FRF Mbps. Then we are having receive signal, and we are having the geometry based MIMO fading channel for millimeter wave environment. Our core objective is to formulate a low complexity, energy efficient hybrid precoding solution that minimizes the preamble and estimation data while maximizing the spectral efficiency. The optimization problem for hybrid precoding is inherently non-complex because it is significantly challenges the traditional analytical techniques. So what we are proposing, we are implementing the meta-heuristic algorithm to reduce this estimation globally and to avoid this complex matrix operation. The specific variants, so what we are using is we are using basically particle swarm optimization with our Kalman hybrid precoding. Then we have again enhanced this PSO with the art colony optimized meta-heuristic algorithm again with the Kalman hybrid precoding. And last one we are again added SALP swarm optimized Kalman optimize meta-heuristic algorithm with our PSO Kalman hybrid precoding. Then we are having we have divided this Kalman baseline filter is there to with this baseband precoder FBB is to predict the unknown variable and minimize the signal interference between the data streams. Then we are having the PSO integration. The PSO integration, what we are added with the Kalman is when we are adding this meta-heuristic algorithm like PSO, SEO, they are fine tuning the signal direction where exactly that signal is going. These are the three integrations what we have integrated with our basic Kalman baseline filter, that is PSO integration. Then we are having PSO ACO enhancement, and then we are having the PSO SSA enhancement. These are the parameters what we are having for PSO, ACO, and then we are having the SSA. Likewise, we are whatever the particle size we are having in the PSO, that is 20. Iteration is also limited to 100. Then we are having the constant cognitive coefficient C1 for PSO is 2. SNR range we have decided for all three simulation parameters is minus 10 dB to 20 dB. When we are actually millimeter wave propagation is a very limited path scattering is there for millimeter wave propagation. So that is why in our study we are having more transmitting antennas, receiving antenna is also fixed. We are just changing in our study, we are just changing the propagation path. Firstly, we are calculating with respect to propagation path, LM is equal to 5, then LM is equal to 10, and then LM is equal to 15. Likewise, we are just seeing what the best performance we are having in terms of spectral efficiency. So when we have analyze the things that when we are increasing the number of paths 1 5 10 15 just 4 studies we have changing the path we have seen uh, uh, the different hybrid precoding algorithm with respect to PSO KHP, PSO SSA KHP, PSO ACO KHP likewise, and then we are seeing the overall performance, and that in overall performance we are seeing the PSO ACO KHP is achieved the highest performance efficiency at 11.69 bits per second hertz. So the conclusion we are having in multi-user beamforming where we are using a millimeter wave communication spectrum, there we are having a large number of antennas. So basic Kalman algorithm is not only sufficient. When we are adding our meta-heuristic algorithm with that Kalman, then we are fine-tuning the signal with respect to hybrid precoding. There, whatever the mathematical calculations are there with respect to inversion of the matrices, what conventional we are having, we are also reducing that complexity. Convergences get fast likewise, and it is cost effective with respect to hurdles what we are coming in the next generation wireless communication system. Hello, sir.
Yes.
Sir, this is my paper what we presented. I do have a study on different meteoristic algorithm just to fine tune the thing, signal where it is going. Initially, only the Kalman is doing the things. It is just predicting where should be the signal there. But with respect to meteoristic algorithm, what we have applied, sir, just studying different meteoristic algorithm with the Kalman, and I'm just seeing how it fine tunes and how the spectral efficiencies get increased, sir.
I
And
think
since we are using, sir, yes, sir.
it's at par work. But to be frank with you, I'm not from the electronics background. I'm from the computer engineering background.
Okay, sir.
So I won't be able to give you the suggestions for this paper.
Okay, sir.
Hmm? So,
Okay.
best luck for you.
Okay, sir. Thank you, sir. Thank you.
Thank you for your presentation.
Thank you, ma'am.
And with that, we've come to the end of the technical session 4E. I sincerely thank all our authors for the excellent presentations and valuable research contributions. I also thank all the participants for being a part of this session of the 11th International Conference on Information and Communications Technology for Sustainable Development, that is ICT4SD 2026. I hope you found today's session informative and enriching. On behalf of the entire organizing committee, we extend a heartfelt gratitude for your continued support, not only for the 11th edition, but also for all the previous editions. We look forward to welcoming you again at the 12th ICT4SD conference in 2027. All presenters will receive their digital certificates via email within 2 working days. The conference proceedings are expected to be published within 7 to 8 months. We kindly request your continued cooperation with the organizing team throughout the publication process. I would also like to express my sincere gratitude to our session chair for effectively chairing this session. And as a token of our appreciation, we present this certificate to you, sir. Would you please like to share a few words with us, Dr. Suresh Limkar?
Yeah. So all the papers are at par industry standards, and most of them have done the research findings. So that's one of the best thing about its 11th edition of this ICT4SD that I found. And thank you for the organizers for confirming my as a session chair opportunity. So once again, I would like to thank organizers and entire team of the ICT4SD for their best wishes.
Thank you, sir.
Thank you for your sir. We really appreciate you taking out your time
Thank
for
you, sir.
this conference. Lastly, I would like to request everyone to please turn on their camera so that we can have a quick snapshot of this session.
भाई मेरे पास तो किसी का नहीं आया